Welcome to Chapter 17, which is Atmospheric Science and Air Pollution. The contents of this particular chapter makes up a significant, not a ginormous, but a significant part of the national exam. So please make sure that you really pay attention to this stuff and really internalize what's going on here. All right. Your first question says, which three gases make up the majority of the atmosphere? That would be nitrogen, which is N2, and that's 78% of the atmosphere. Oxygen, which is O2, and 21% of the atmosphere. And then argon, which is a noble gas, that's about 0.9% of the atmosphere. In that teensy-weensy other amount is where we have all sorts of gases that have a giant impact on our environment. Okay, 4 layers of the atmosphere going from the surface of the Earth towards the sun. You have the troposphere, stratosphere, mesosphere, and thermosphere. And if you look at that graphic on the left, that yellow line is the temperature. So, troposphere, that's where weather occurs. That is where air pollution builds up. So the temperature goes down as you go up. It gets colder as you go up in the sky. Stratosphere, that is where the ozone layer is. We're going to talk about that a little bit later. The temperature goes up as you go up. Then you hit the mesosphere. It gets cold again. And then the thermosphere. Temperature goes up again. So up, down, up, down. Definitely know where weather occurs, where air pollution occurs, and where the ozone layer is. Stratospheric ozone. That will become an important distinction a little bit later on. Also realize that the troposphere is like super ridiculously thin. What is the purpose of stratospheric ozone? It absorbs and scatters UV rays from the sun, which in turn reduces tissue damage and DNA mutations in organisms. So it absolutely blocks the UVB and UVC, absolutely UVC for sure, a little bit of UVA getting through. And if you look there on the right-hand side, the way that ozone is produced is under the influence of that UV light. It actually hits the oxygen already in the air, splits that apart, and then one oxygen, which is called radical, hits another O2 and forms ozone. So the UV radiation that the ozone protects us from, it actually creates the ozone, so kind of cool. All right, what is the link between atmospheric pressure and altitude? As you go up in the sky, air pressure goes down. And this should be familiar to anyone who's ever climbed a mountain or gone to a city that has a high altitude. Because there's less pressure, the density of the air is less, and it's tougher for you to breathe in enough oxygen for survival. All right, what is relative humidity and how is it related to temperature? Relative humidity is the ratio of water vapor in air to other dry components in the air. The relative humidity goes up as the air temperature goes up. So in other words, the warmer it gets, the more moisture that the air can hold on to, that goes into the air. And also the warmer that the air gets, the more moisture it can hold on to. And that's going to come into play when we talk about climate change in another chapter. And here are the problems. High humidity means organisms that do sweat cannot sweat to cool off. And then warmer air holds more water, so there's less condensation and rain. Think about this, what this means in terms of global warming. It means the warmer that it gets, the less rain we're going to get, and the less fresh water we'll have access to because it'll be in the atmosphere. And it will also be muggier, and we will be less able to cool ourselves off as it gets hotter because it's so muggy. Why is it on average colder at the poles than it is at the equator? Because the sun is the sun. It has to do with a term called insolation. The sun has the same amount of energy no matter what side of that sphere that the energy is coming from. However, look at how it strikes the equator versus how it strikes the poles. It is the same amount of energy over a greater area at the poles, which means that its overall intensity is less. So it's all about the density of the power. Same amount of power hitting the different parts of the Earth, but because of the curvature of the Earth, because we're a sphere and not a flat piece of paper, the concentration of that sunlight varies depending on where you are on the globe. Why do seasons occur? We've talked about this before. It's the tilt of the Earth's axis. We are almost a completely spherical path around the sun. All right, what is the difference between weather and climate? Weather is what's happening today. Climate is the area's general pattern of atmospheric or weather conditions measured over a long period of time. Remember what Mark Twain said? Climate is what we expect, and weather is what we get. All right, understand in brief what a front is. A front is a boundary between air masses that differ in temperature and moisture content, which also means their densities are different. And a cold front brings thunderstorms. Think about Florida in the wintertime. Anytime it rains, it gets cold. So those rainstorms are being pushed by that cold front. So cold front means rain. And what is the implication for us? The warmer it gets, uniformly, the less cold fronts we'll have and the less rain gets driven by our weather. And then what type of pressure system is usually associated with fair weather? That's high pressure. And with thunderstorms, low pressure. Again, if we have an overall warming of the globe, it means you're going to have less differences in temperature of the air, less winds, less of this stuff happening, less rainstorms. That's where all of this is going towards. What is the relationship between an inversion layer and the buildup of air pollution? Describe the general temperature makeup of an inversion layer and identify the natural geographic feature that enhances the impact of an inversion layer on a city's air pollution. Just to back up for a second, if you're wondering why it is that we're going over all of this, because we're going to be talking about air pollution at the end of this chapter, and you need to understand what type of atmospheric conditions can make things worse. So, and then also how things like climate change play into the natural system of our atmosphere. All right, back to this. So, normally, and you have a figure in your book. It is figure 17.8 if you want to take a look at it. The way that things normally work around a city is that the air around the bottom of a city where the sidewalks are is warm, and then the higher you go up, it cools off, which is what the troposphere normally does. However, there are times when a city cools off, like at night. And especially when you have a city that's in a valley, which means it's ringed by mountains, it's not hit by the sun until a little bit later on. So sometimes what happens is you have this thermal inversion. You have cool air at the bottom of the city, and then this lid of warm air comes sliding in, and then you have cool air above it. So basically it's like a lid on the bowl that is the valley. And that means that any pollution that you have when that thermal inversion comes in just builds up underneath the lid. So things that are bad, like smog, which we haven't talked about yet, get worse because they have no way of blowing away. So normally air goes from warm in the city to cool as you go up. But when you have a cool, warm, cool situation, that warm layer acts like a lid, and it means that any pollution that builds up in that city, just its density increases, and thus its effects become more prominent over time. When you have a normal situation going on, you then have the pollution can float away. See, like this. You're also going to notice here this is normal, and then that's the thermal layer. Okay, we're good. All right, another thing you may want to do is kind of pause and kind of read this. All right, but we are going to explain this in a little bit. All right, and the buildup of pollution, by the way, can lead to like people dying, which we're going to talk about in a second. All right, identify where the different types of convection cells occur globally. Where do moist biomes occur because of the cells? Where do dry biomes occur because of the cells? What drives the convection cells? Okay, this is the 6-cell model that we've talked about. 3 above the equator, 3 below. The ones that are closest to the equator are called Hadley, then Feral, and then, shocking absolutely no one, polar. All right, so what causes these things to happen is convection. Warm air rises, cold air falls, and these cells think about them like a tube that encases its position on the globe. And so where the 2 Hadley cells meet at the equator, that's where it rains and it's moist. Well, no duh, that's where the rainforests are. At 30 degrees above and below, because those cells no longer have any water in them, 30 degrees above and below the equator is where deserts normally occur. So that's where the Hadley and the Feral cells meet. And then you also have a moist area where the feral and the polar cells meet. You can see nobody cares about that at the South Pole area because that is the area where there is literally no land. It is the only place on the globe where you can circumnavigate the globe and not hit land not one time. Alright, so here's some more. Here's some more. Always feel free to stop this video. Yes, sorry about that. And why do our winds end up curving like this when you would think that they would be straight because of the convection cells? The answer is the Coriolis effect. And what I'm going to do right now is, you're not going to be able to know this from your end, but I'm going to pause this video because I have somewhere to be briefly, and then I'm going to come back and finish it up, post it as quick as I can. Alright, so here we go back, and let's see what I'm missing. Okay, we just finished the Coriolis effect, so let's go ahead and start from here again. We are back to, let's see, identify 3 natural sources of air pollution. Realize what air pollution is. Here's a definition for you you can read. And you've got dust, and it's not just like dust blown out in the street. I'm talking about like dust from Africa that ends up in South America. Pollutants from wildfires and volcanoes. Wildfires is combustion, so you're going to have things like ash and carbon dioxide, and then volcanoes are a natural source of sulfur dioxide, and then things called volatile organics that are released by plants. I'm going to talk about that in a few minutes. So do you realize that some of the air pollution we're talking about is naturally occurring, but the majority of it comes from us? And when I talk about pollutants, I'm going to refer to some as primary and some as secondary. I have a handy-dandy reference sheet that you're going to get in a couple of class periods for your reference as you are studying for the national exam that lists the primary and secondary pollutants you need to be familiar with as you move forward to take the test. It's really nice. It's a single-sided, single sheet of paper. Good to study. Alright, so differentiate between primary and secondary pollutants. Primary pollutants are those that are emitted into the troposphere in a form that can be directly harmful or that can react to form harmful compounds. So it's that first pollutant. Secondary pollutants are those that are produced when primary pollutants interact with or react with stuff in the atmosphere to create harmful substances. And we're going to be going through and naming things as primary and secondary as we move on. Do realize in general that air quality is improving in developed countries because we pass things like laws and have things like fines, but developed countries, excuse me, but in developing countries, laws aren't there, different types of pollution that are a problem. We're going to talk about it in a second, but also realize that here in the developed countries, like the United States, our outdoor air is great, our indoor air not so much. We're going to get to that momentarily. Okay, here are some sources and types of air pollution. We've got primary pollutants and secondary pollutants. You can pause here and take a look at them. Alright, here in the United States, we have considerably cleaned up our air by passing something called the Clean Air Act. And it sets standards for air quality, sets limits on emissions, and then there are fines and other things that you can do to when violations take place. There are 6 what are called criteria pollutants that the EPA, who administers this law, uses to determine if air is, quote, good or, quote, bad. This acronym, NAAQ, N-A-A-Q, National Ambient Air Quality Standards, is the blanket acronym for these 6 criteria pollutants. They're the ones that are measured and, again, determine if the air is good or bad. It's carbon monoxide, sulfur dioxide, nitrogen dioxide. We're going to be a little bit more specific with that, well, a little bit more general with that. Tropospheric ozone. Remember we talked about ozone in the stratosphere? Ozone is good up high and bad nearby. And then lead and particulate matter. So let's go ahead and talk about all of them. The first criteria pollutant is called carbon monoxide, 1C1O. It comes from incomplete combustion. It's odorless and colorless. It usually comes from cars, and it is a primary pollutant, and when it gets into the bloodstream, it permanently binds with hemoglobin to keep it from uptaking oxygen. So it's if somebody's poisoned with carbon monoxide, it's not enough to get them out of there. You've actually got to clean their blood so that they can process oxygen again. Okay, the next criteria pollutant is called sulfur dioxide. It's SO2, and it's absolutely irritating in its odor. It can cause upper respiratory issues, but its biggest problem is when it combines with water vapor in the air and forms a secondary pollutant, which is sulfuric acid. You need to know that's H2SO4, and then it can form a solid version of itself that has this ion called sulfate in it. Nitrogen oxides, this includes NO, which is nitrogen monoxide, and NO2, which is nitrogen dioxide. Collectively, they are known as NOx, with that X here standing for either 1 or 2. Also, foul smelling causes lung irritation, suppresses plant growth, but again, its biggest problem is that it combines with water vapor in the air and forms nitric acid, which is HNO3. And we're going to talk about what acid rain is in a little bit. Okay, ozone, and this is tropospheric ozone formed in the troposphere instead of the stratosphere, and it's not good here. It doesn't protect us from UV light, and it causes lung irritation and environmental impact. It damages plants, and it's very degrading to tissues in general. It's formed from something called photochemical smog, which you're going to be learning about momentarily. So this is a secondary pollutant, okay? CO is primary, SO2 is primary, NOx, those are primary, but tropospheric ozone, or O3, is a secondary pollutant. Lead used to come from gasoline. It was an additive in our gasoline at one point, and then we figured out it was a bad idea to have a heavy metal being released into the air where it can bioaccumulate in our tissues. Now you usually see it in developing countries when it comes from the industrial smelting of metal. That's where you refine it. This is a primary pollutant, and then you have what's called particulates, which is dust and ash. Some of it is ultrafine, which is right around the diameter of a human hair. Most of it comes from natural sources, some of it not so much. Everything that's in the air, if you have to guess an effect, always go with lung or mucous membrane irritation. Mucous membranes include anything that's moist in your head area. So that includes like your eyes and your nose and your mouth, and then when you breathe in, your lungs. That should make sense. It's in the air, it's going to bother your lungs. Okay, so those 6 were the criteria pollutants that the EPA uses to determine if air is good or bad. All right, what are VOC and where do they come from? VOC, VOC, stands for volatile organic compounds. Volatile means it turns into a gas readily. So it is, and organic means it's got hydrogen and carbon in it. So these are long chain molecules like methane, but more like terpenes, like think the way that eucalyptus smells, or butane, or paint thinner. Think about those smells, and the reason you can smell them so strongly is because they're volatile and they're organic. And they're irritating on their own, but their problem is they're part of the process that causes, that creates that tropospheric ozone. And do realize that things like benzene can lead to leukemia. All right, next question is, list 3 specific things that have helped to reduce the amount of air pollution that is emitted in the U.S. Cleaner cars, the catalytic converters, sulfur dioxide reductions. There's something called a permit trading program. So you say, hey, you company, you can only make this much, and hey, you company, you can only make this much sulfur dioxide. But if you're really efficient at what you do, you have this extra credit, and then you can sell that to someone else so that they can pollute more. So this is actually, going green has become a way of making money. Scrubbers, we've talked about before. I'm going to refresh your memory in a second. And then we've phased out leaded gas here in the United States. All right, don't forget what catalytic converters do. They take things like NOx and carbon monoxide and those hydrocarbons, and they turn them into water vapor, carbon dioxide, and atmospheric nitrogen. Scrubbers physically and through charges take particulate matter out, and then chemically can go ahead and get rid of some of those chemicals like SO2. Where does the COT pollutants go? They go into what's called a secure landfill for toxic waste. We will talk about that in a chapter or 2. So we now have, how does industrial smog form? Coal is burned. What is its characteristic color? Gray. What are its main components? So when you burn the coal, you form carbon monoxide, carbon dioxide, sulfur dioxide, which then turns into sulfuric acid, which is H2SO4, and something called ammonium sulfate, which is kind of a solid version of that acid. And I'm going to show you a picture here in a second of that process. Two places where there was a small window of time in which many people died from industrial smog. One was London, England in 1952, and then 4 years before that in 1948, Donora, Pennsylvania. That's a place you need to know for the national exam for sure. Thousands of people sickened and died because of it. Donora is also in a valley area, so the reason the industrial smog became such a terrible problem was because a temperature or a thermal inversion came in and just trapped it all there. Okay, here is industrial smog. You're welcome to pause the video and take a look at that. You don't need to know these processes very well. Just know what you start with and then where things end up. Please also realize in industrial smog, this is where you can have mercury vapor because coal is usually one of its impurities is mercury. And here's what it looks like. Here is the bad old days. And the second kind of smog you need to know about is called photochemical smog. Listen to the word. Photo means light, chemical is chemicals. So this one is activated by sunlight. Heat and dry conditions help as well. So you've got that shouldn't say NO2, it really should say NOx. This begins to sound like a Dr. Seuss tale. Vox plus NOx plus heat plus sunlight yields tropospheric ozone, nitric acid, aldehydes, and something called PANs, which are peroxacyl nitrates. What do you really need to know for the national exam? Listen to what I'm saying. Vox plus NOx plus water vapor in the presence of sunlight produces tropospheric ozone, nitric acid, and PANs. So industrial smog is largely a sulfur-based thing. This is a nitrogen-based thing. And of the two, photochemical smog is worse. It is absolutely associated with urban industrial areas, and it gets worse as the day progresses because, the sunlight increases. Weekdays, Mondays usually start off great. Fridays are the worst because it builds up over time. Its characteristic color is brown, and we've already talked about its main components, which you can see right here. And again here, this is an unretouched photo of photochemical smog. Here it is right here, and you can absolutely see the thermal inversion keeping this stuff in place. Let's see. Give the short-term and long-term effects of air pollution. Short-term, respiratory problems for humans. Long-term are lingering effects of acid rain, which we're going to talk about in a second. Decreased photosynthesis, your quality of life declines. Long-term respiratory effects, asthma attacks. It can be blown to rural areas thousands of miles away to affect the organisms there. And obviously, if you have heavy metals like lead or mercury, it can bioaccumulate. Remember, all of this stuff we've talked about affects young people, old people, and those with pre-existing conditions the most. Right, and here's a respiratory system if you have no clue. All right, so you need to keep these types of pollution straight in your head. Everything I just talked about happens in the troposphere, where weather occurs. So also think about this. One of the best ways to make smog go away is for it to rain. All right, now let's go into the next layer of the atmosphere, the stratosphere. This is where the ozone layer is. The stuff that happens in the troposphere, like the smog, does not affect the stratosphere. This is a whole other thing. All right, the ozone layer is thinning. I'm sure you've heard of this before. I'm going to mention this again in class. It's seasonally worse in September. It's also worse at the poles. It's very thin there. What class of chemicals is largely responsible for the depletion of stratospheric ozone? They're called CFCs, chlorofluorocarbons. It is a carbon in the middle, and then fluorines and chlorines coming off in a tetrahedral pattern. So you've got 4 total. Nobody could figure out why the ozone layer was thinning until 1984 when Rowland and Molina figured this out. Up until that point, and this is a part of this question, give examples of products that contain this class of chemical. refrigerants like Freon, fire extinguishers, propellants, and aerosols like hairspray. These things really don't contain CFCs since the mid-'80s when we're like, oh, we're doing this to ourselves. So how does this happen? I'm going to show you some pictures in a second, but here's the basic mechanism. All right, light hits the CFC. Chlorine pops off. Chlorine hits the ozone. Remember that it's O3, splitting it into O2 and then O, which is called a free radical. Chlorine rides along with the O, so that's ClO, until it hits another O to form O2. The chlorine pops off and it starts the cycle again. Remember, this is happening in the stratosphere. So here's the thinning that's occurring. Here's the process. You need to be able to describe that in an FRQ. All right, so what is the name of the international? And here are the problems. Skin cancer. This is why skin cancer rates have gone up. All right, so what is the name of the international agreement that restricted CFC production? It's called the Montreal Protocol. Why will we not see the full effect of this agreement for some time? CFCs last in the atmosphere sometimes for hundreds of years before they eventually trickle out the top in the mesosphere and the thermosphere. We're starting to see some stabilization that's going on, but we're not going to see real healing of the ozone layer until it's all gone. Okay, last type of air pollution we're going to talk about is called acid deposition. We're back in the troposphere again. How does acid deposition form? Two kinds. SO2 combines with water vapor in the presence of heat and light to form sulfuric acid, which is H2SO4. NOx, which remember is a combination of NO and NO2, combines with water vapor to form nitric acid, which is HNO3. So, sulfuric acid is a problem with industrial smog. Nitric acid is a problem with photochemical smog. It's usually not a problem in urban areas because smokestacks are usually really tall. Put the stuff in the jet stream. It becomes a problem in rural areas where they're like, we didn't do this. Where's the worst acid deposition? No, for air pollution, just go with China, really. All right, so it can deposit as rain, snow, sleet, hail, or also as dry particles, as a salt. Give some examples of its form. We've already talked about that. Where does acid deposition often fall? Again, thousands of kilometers away, like rural areas and forests. All right, number of harmful effects. Acid deposition does not fall on plants and animals and burn them. It usually has the pH of like lemon juice. So what is the deal? What does acid deposition do to nutrients in the soil? It leaches out calcium, magnesium, and potassium ions from topsoil. So what it does is it takes them in its solid form, it converts them to ions, which are soluble in water. That means that they're dissolved in the water, and the water percolates downward into the subsoil. It's called leaching. And those nutrients end up in the subsoil where roots can't get at them. So that's one way that acid deposition is a problem. And that happens because the hydrogen in the acid takes the place of the positive cations. So it puts the nutrients in the water, and then they leach into the subsoil. All right, what is the effect of this process? Plants starve to death. So that's why they die. It's not because they're getting burned by the rain. It's because they starve to death. What does acid deposition do to toxic metal ions? It mobilizes them. So it takes aluminum, zinc, and mercury and copper, and it converts them from solids to ions, which are then can move around in water, and they go places. What is the effect of this process on both terrestrial plants and aquatic organisms? If you have things like zinc, mercury, and copper, you have biomagnification because those are heavy metals. Aluminum does some very specific things. It hinders water and nutrient uptake in plants, and then it kills fish by damaging their gills. So once the stuff gets into the water, it can just go anywhere, and also can end up in our groundwater supply, in our rivers and our lakes. What are the impact of acid deposition what is the impact of acid deposition on man-made structure? It quickly wears away antiquities. What that means is things that have been around for thousands and thousands of years. We're talking about like Greek and Roman architecture wearing away. We're losing our history to acid rain. In Greece, they've actually had to take parts of Acropolis and Parthenon and bring them inside because acid rain has been melting it away. Okay, so let me show you some pictures. Here you can see acid rain being created in industrialized areas and ending up in rural areas. Why is this a problem? This is usually where we grow our food, and you're going to find it really tough to grow food if they're not getting nutrients. And then also, like fish and stuff dying bad. Here again, and this is not because the leaves got burned off, this is because they're starving to death, those plants. Here again. All right, and here are things being worn away. These are called caryatids, and it looks like they're being melted. I'm going to stop here for the quiz, but I'm going to give you the rest of the questions that are on here because you're going to need to know them for the national exam and then also for your test. So this is Chapter 17, Part 2. You're only responsible for Chapter 17, Part 1 on the quiz. Based on the given example of the ways that energy efficiency has worsened indoor air pollution, I don't know what that is. What may be the best way to regularly reduce air pollution within a home or a building? Let me get to that in a second. All right. Indoor air pollution is a serious problem. I'm going to give you the big picture here. In developing countries, remember you burn stuff inside, not a lot of ventilation, so anything you burn turns into a vapor, you breathe it in. Particulate matter, carbon monoxide, carbon dioxide builds up. Any impurities, especially if you're burning coal, you're going to end up with mercury. So you're talking about everything from respiratory issues to emphysema to premature death, and also heart attacks can come from this as well. And the poor are going to suffer the greatest risk because they don't have any indoor air pollution, not only at home, but also on the job. In developing countries, you do not have laws that protect workers' rights. In developed countries, we have taken care of our outdoor air pollution, but we have hermetically sealed ourselves in our houses. And so, if we have all of these things in our homes that give off pollution, which we're going to talk about in a second, the best way to rid yourself of that is to open your windows on a regular basis. Do them in a strategic fashion so you create a cross current so you get that indoor air pollution out and get that fresh air in. Do it weekly. All right. 11 of the common air pollutants are higher inside than outside, even in vehicles, because think about it. Think about the people you know and think about yourself. People now are spending 70 to 98% of their time indoors. So whatever you do in your house, problem. And these are the people at greatest risk from indoor air pollution. This should come as no surprise. All right, so one question that you had on here was, okay, we've already talked about the impact difference between developed and developing countries. What are some of the effects of indoor air pollution in developing countries? Pneumonia, bronchitis, allergies, sinus infections, cataracts even, asthma, emphysema, heart disease, cancer, and premature death. All right, what are the two most dangerous indoor air pollutions in the developed world? That would be tobacco, smoke, and radon. Both of those things cause lung cancer. We discussed what radon was in a previous chapter. VOCs are also an issue. Let me back up here a second. VOCs, remember, are volatile organic compounds that are found in everything from plastic to oil to perfume to paint to cleaning fluid to adhesives to pesticide to furniture to carpet to printers when they print. It's that smell that you smell in the copy room when it's been going for a while, or that new car smell, or what new furniture smells like, or the smell that you smell when you get stuff from the dry cleaners and you open the bag for the first time, which, by the way, you should be opening the bag outside, because if you're bringing that in, you're bringing volatile organic compounds into the smallest, most closed room in your house, your closet, and so you're leaving these little tiny poison pills in plastic bags. And then you're opening them in your closet and you're increasing the indoor air pollution in a room that you hopefully go into pretty much every day. So open your dry cleaning outside. And we do know that stuff like formaldehyde, which is a kind of volatile organic compound, yes, formaldehyde that's used to preserve bodies, you also find in dry cleaning fluid. You find it in nail products. It leads to the irritation of mucous membranes, skin allergies, and Lou Gehrig's disease also. All right, here are some other ones. What are the health effects of exposure to fungi, mold, and mildew? Sorry about that. Allergies, asthma, other respiratory ailments. Spores are very hard to get rid of once they've settled into your lungs. They don't really respond to antibiotics because they're not bacteria. And then what is a sick building syndrome? It's general, non-specific, but widespread allergic responses in humans who are all in the same building. So that's if you've got this buildup of Vox in a building that doesn't open very often at all, and then you probably have some mold or mildew that's growing in the walls. Here are some examples of indoor air pollution in the developed world on the left and in the developing world on the right. Look at the back of this wall where they cook. If that's the way the back of the wall looks, you can only imagine what their lungs might look like. And then here are all the things that you're exposed to in your house. If you're wondering how to reduce this, get people to start cooking outside if they feel unsafe doing that. There are new stoves that burn cleaner and actually use less wood, solar cookers, ways that they can go ahead, solar panels, individual solar panels, so they can start cooking off of electricity. So there are lots of ways of reducing this that are not only better for human health, but then also better for the environment. And here's some more indoor air pollution. These are working conditions in a developing country. This is something I'm going to go over in class. So just realize that Bhopal, India is a place that you're going to need to know about. And yeah. All right, so we're done.